Okay then, so now you've got Mizer set up, let's actually run it and do some interesting things with it. So whenever you begin a new session with RStudio and you want to use Mizer, you should type this command here, library Mizer, and run that, and that will prime all the different things that R is going to need to be able to run Mizer. And now let's start setting up a community-based model. So the community-based model is the simplest type of marine ecosystem model that's implemented by Mizer. It's simpler than the others because it only has one species and the recruitment is held at a constant level. So when you're going to use Mizer to do some simulations, you need to store the parameters, the setup of those simulations, and they're stored as what's called a Mizer Params Object. So we're going to make such an object. Let's call it Params. We could call it anything we wanted. And we'll use this left pointing arrow here. This basically means is defined as in R code. Okay, so this params thing is going to be defined as the output of this Mizer command here, set community model. And this is sort of like a function, and we need to put different inputs into it to tell Mizer how to set up this Mizer Params object. So we can put various settings in. Let's just go for something simple. We'll set the level of background mortality. Let's set that to be 0.1. And let's set the feeding level, F0, to be 0.7. And the fraction of energy passed on from prey to predator, we'll set that to be 0.2. And the level of recruitment, we'll set that to be 4 times 10 to the 7. Okay, we'll press return, and we've made a params object. You can see that that's happened if you go to this panel up here and look under the environment section. Okay, so let's have a look at this params object. What kind of data is stored here? Well, the data in such an object are stored in different kind of pieces called slots. And we can see what they're called simply by typing slot names of params. And that shows us the different slots. Now, if we want to look at a particular slot, let's say W, well, we can look at it like this. We type params at W. If we just run that, that shows us what this slot is. It turns out this is a list of all the different weights at which we're going to track the abundance of fish at, but the details are not too important. I do want to tell you, however, how you can get at particular elements in a vector like this. So say you wanted to look at the third element, you can just do that with square brackets, like so. So the third size entry is 0.0015 grams roughly. Okay, so we've made this params object which has the basic setup for our community-based model. Now let's run the thing. So we're going to make a sort of object to store the output of this simulation. We'll call it sim. And to actually do the simulation, we run this command called project. So project is a Mizer command which basically you put in the params object. Whoops, that was a mistake. Let's do this again. We put in the params object. I hit enter too fast then. We put in the params object and we also put in the runtime. So let's run this for 50 years and we won't have any fishing. So let's turn the fishing effort to 0. So if we press enter, this is now running the simulation. And that stores it as this thing called sim. We could have called it anything we want. So okay, we've run a Mizer simulation. Now how do we actually see what's happened? Well, there are various commands you can use to plot different aspects of this simulation data. The simplest and easiest one is just called plot. So plot of sim. We do that and press enter. Now if we go to the plot section here at the bottom right, we see there are various plots showing us different aspects of this simulation. It's a bit difficult to see because this panel's too small on my screen, but I shall press zoom here to make this pop out. And we can see there's lots of interesting information about this simulation being visualized here. So at the top right, this is probably the most useful one often. This shows how the biomass of our species is changing over time. And we see that it's reaching a constant level, indicating that this system's probably going to a steady state within maybe about 5 years. And these other plots here are showing the feeding level, the predation mortality, the fishing mortality, and the biomass density over different sizes. And these pictures are all given for the sort of final state of our simulation.